Hi everyone! Well, today we will be looking at the essential question of how do you find the area of a composite figure? So by the end of today's lesson, you should be able to find area of multiple shapes that have been stuck together. Our first shape that we're going to be looking at, our first composite shape, is like the one that we saw yesterday in example A. We're going to use the same one that looked like a sideways snow cone or a baseball diamond, where we had a right triangle and then we had our semicircle here. And it was connected with a dotted line. We have 8 feet. We had 6 feet. We had a right angle here. And then we also had 10 feet here. So our job today is going to be to find the exact same thing, except we're using the same shape, but we're finding the area. So we know in order to find the area of a triangle, so let's look at this triangle shape, we want to find the area here. So how much space does this triangle take up? Well, this triangle takes up the area of 1/2 times the base times the height. So let's look at the base. The base is 6, the height is 8, and then we're going to cut all of that in half. So in order to find the area of this space here, 6 times 8, we get, 6 times 8 is going to be 48, and then we're going to cut it in half and get a total of 24 feet. So that is the first area. But we also have the top of this shape. Okay, we also have like this semicircle piece that we need to find the area of. So we're going to use the 10 feet right there in the middle, that 10 feet diagonal, to find the semicircle. So to find the semicircle area, we're going to, remember it's pi times r squared, and then cut it in half. So pi times r squared, and then we're going to cut in half. So 3.14 times the radius, well, diameter equals 10, the radius equals 5. So we're going to do 5 squared, and then we're going to chop that in half. So 3.14 times 5 divided by 2 gives us a total of 39.25 feet squared. This one is also feet squared. Now we're going to combine these two shapes for the entire thing. So 39 plus 24. So we're going to take this 24 plus 39.25. And that gives us 13, so 63.25 feet squared. So again, we're working with a composite shape. We have two shapes added together to find the total. Okay, let's look at another example. So we are going to look at, let's see if they give me another example that we can use here. I want to try to do something different than what we did yesterday. Let's find the area of a shape that looks like this. So example B, we have a parallelogram. And a parallelogram is actually just two triangles right? So like you've just cut the corner off of here and slid it over. So it's also a composite shape. We can use this information to help us find the area of this composite shape here, which is a parallelogram. So let's say that this right here is 12 millimeters. And then we have 4 millimeters. From here to here, it's 8 millimeters. This is also 4 millimeters. And our hypotenuse, or the angle here, is going to be 8 millimeters. Okay, so let's first start with one of the triangles. So let's start with, we're going to end up having 2 triangles. So let's solve for one triangle. So we want to find the area of a triangle by using the information that we can use from this picture. Okay, so let's start with this one here. We're going to use, we don't really need to worry about the hypotenuse. And the reason is because that we could use for the perimeter. So that is trick. We don't need that information. In order to find the area of a triangle here, so we have triangles. We are using base times height, again, divided by 2. So our base is 4. Our height, which was on the right angle there, is 8. And then we divide by 2. So 8 times 4 is 32 divided by 2. And that gives us a total of, what is that, 16? So total of 16 millimeters squared. Okay, so this triangle is 16 millimeters, which means that this triangle here is also 16 millimeters squared. Okay, so we have 2 that are 16 millimeters squared. And we now need to find, so let's go ahead and add those together for a total of 32. And now we have this rectangle here. So on this rectangle, we have 12 times 8. So we're going to look at the rectangle now. And our rectangle has a height of 8 and a base of 12. So all of this part on the inside here, rectangle. Again, these are so much easier to solve if you draw it out and color it yourself so that you can see the different parts. So we have base times height, and that's going to equal 12 times 8. And 12 times 8, 16, carry the 1, 96 millimeters squared. Okay, now we are ready to add 96 and 32 for a total of 9, 12, 128 millimeters squared. That is the total area. Okay, all right, let's do one more example, and then I am going to give you your try it. So let's look at an example. We have a rectangle here, and this rectangle has 6 feet here, and then there is a semicircle on top, and then this is 4 feet. Okay, so it looks like we have like the top of a basketball key again, and now we're going to solve this problem. Okay, so we have a rectangle and a semicircle. I know about rectangles that if this length is 6 feet, this length is also 6 feet. And so I'm going to use this information to help me solve 6 feet by 4 feet. So 6 times 4, that's going to give me 24. So this whole inside right here is 24 feet. But I need to also worry about the top of this basketball hoop, or court, I mean. And so I have, let's see here. I have 6 as my diameter. So this is my rectangle. It's 24 feet squared. But I care about this semicircle now. So I need to worry about the semi. And the semicircle is pi r squared divided by 2. Right now I have a diameter of 6, which means that my radius is 3. So I'm going to multiply 3.14 times 3 squared, and then I'm going to divide that by 2. So I know that 3.14 times 9, and then I'm dividing that by 2. Sorry that my dog is barking again. Okay, so we're going to take and we are going to multiply 3.14 times 9. So 3.14 times 9, and that gives us 28.26 divided in half, divide by 2. And that gives us 14.13 feet squared. So the whole inside of this shape is 14.13. And I have 24. So I'm going to add both of these together. 14.13 plus 24. That's going to give me a 38.13 feet squared. I found the area of a composite shape. Okay. All right. It is your turn now to do a try it or two. Let's see what we have in store for you. I know that yesterday we did a couple different shapes. So let's see what we had going on yesterday. Oh, goodness. Don't really care for these shapes. Okay, let's do this, try it. So, try it. Number 1, we have a rectangular, triangular composite shape like yesterday. And here this says this is 3 centimeters, 4 centimeters, and 7 centimeters. Please find the area of try it number 1. Ooh, I kind of like this one. Okay, and try it number 2. Try it number 2 is interesting as well because it goes like this. All right, try it number 2. You have this stair-looking thing. And here we have 18 meters, 7 meters, 8 meters, 11 meters, 7 meters, and 10 meters, 3 meters, and then this whole length over here is 28 meters. Okay, so go ahead and hit pause right now, and when you're ready, come on back and check your work. All right, example 1. Example 1, we have 4 by 7 to fill in this box right here. So 4 times 7 is 28. And then this 4 right here is the same length over here for this here. So I'm going to take for my triangle, for the triangle, The triangle is going to be 4 times 3 divided by 2. Base times height divided by 2. So 12 divided by 2 is 6. So I am now going to add 28 plus 6. And 28 plus 6 gives me 34 centimeters squared. So 8 is 14. Carry the 1. 34 centimeters squared. That is my composite shape. Okay, again, it's easier to color these in, draw them out and color them in, especially when you get one that looks like this number 2. This one could be a really fun one if we think about it. Okay, so let's look at the information that we know. We can actually cut this into a couple different pieces here. We can cut this here, and we can solve this rectangle by using 3 meters by 28. So our first one is 3 by 28. Okay. Another meter that we could use, or another way we could cut this, is now we can then cut right here. And we know that this little chunk is 10. So if I subtract 28 from the long one and I remove this chunk of 10 minus 10, I get 18. So I know that this length here is 18 by 7. So I get 18 by 7. So my second one is 18 by 7. And then last but not least, this one's actually colored in for you right here. And it says it's 8 by 7. So I just need an 8 by 7. Okay, now I can solve all of these. This one's kind of fun because it's like a mystery to solve. So let's go ahead. 3 times 28, and that gives me 84. So I get 84 meters squared. For the next piece, I have 18 times 7, and that gives me, wait, why is that one? Let me double check that. 18 times 7. Yeah, 126. That gives me 126 meters squared. And last but not least, I have 8 by 7. 8, well, that's just 56. We already knew that one. 56 meters squared. Now we're going to add all these totals together. So 56 plus 126 plus 84, and that's going to give me a grand total of 266 meters squared. All right, how did you do on this? Now go ahead and answer your essential question. How do you find the area of composite shapes? And then put your level of understanding out to the side. When you're finished, you can come on back to the Google Meet and ask for help, or you can do your practice work. As always, I appreciate all of your hard work and effort, and make it a great